This is a lesson for Algebra for 7-2, day 4. What you're doing today is setting up and also graphing word problems. The word at least means greater than or equal to. You have to be at least 16 years old to drive a car. You could be equal to 16 or more than 16 and drive a car, but you can't be less than 16 and drive a car legally. At most, the word at most means less than or equal to. If you think about going to an amusement park and riding kiddie rides, there's normally a height limit. The most you could be is 48 inches to ride this kiddie ride. So you could be less than 48 or equal to 48, but you can't be more than 48 because maybe you don't fit in it. So it's less than or equal to. Maximum, it's like a maximum height. 48 inches is the tallest that you could be to ride the ride. Could you be less than it? Sure. Could you be equal to it? Sure. So it's less than or equal to. Minimum, that's the lowest that you could be. The minimum driving age is 16 years old. So you could be equal to 16 or more than 16, but you can't be less than that. More than is greater than, less than is less than. No more than. It could be equal to it or it could be less than it, but it can't be more than it or greater than it. No less than, it could be greater than or equal to. You have to be careful sometimes in the context of problems because of how a problem is worded. It might be slightly different. So let's take a look at this first one. We're just going to define our variables and then set up equations. Ben wants to score at least 30 points during the basketball game. His points will come from a combination of 2-pointers and 3-pointers. We're going to let X be the 2-point baskets, and we're going to let Y be the 3-point baskets. 2-pointers are worth 2 points. I know that sounds sort of weird, but that's what it is. A 2-point basket is worth 2 points. So a 2-point basket times the number of 2-point baskets made, plus a 3-point basket times the number of 3-point baskets made. He wants at least 30 points. So he wants greater than or equal to 30 points. That would be your equation. We're not solving anything in this particular one. Now, Mrs. Andrews has $100. That's all that she can spend. Could she spend less than 100? Sure. Could she spend equal to 100? Sure. But she can't spend more than 100 if she only has $100. So she can spend less than it or equal to it. She's buying some leggings that are $10 each and shirts that are $20 each. So we have leggings. I'm going to use the capital letter L for leggings. And she has shirts. Make sure that your uppercase L doesn't look like a 1 and your lowercase s does not look like a 5. So she's buying leggings that are $10 each. So $10 times the number of leggings plus $20 times the number of shirts, and she can spend less than or equal to $100 because that's all that she has. So this one didn't specifically tell you which symbol to use, but in the context of the question, it lets you know what symbol to use. Now we come to these type of questions. I'm going to be honest with you. These type of questions are very hard and very long to solve. So Mrs. Andrews charges $10 for a small henna tattoo and $25 for a large henna tattoo. It takes 15 minutes to create a small and 30 minutes for a large. She'll be at a fair for 6 hours and hopes to make at least $200. So we have two different things going on here. We have small and we have large. I'm going to let X equal my small, and I'm going to let Y equal my large tattoo. So let's talk about the money first. Talking about the money, small tattoos are $10 each. So $10 times the number of small tattoos plus $25 times a large. And she wants to make at least $200, so greater than or equal to 200. Now, the second equation that we have is time. For the time, we have different units of measure. We have minutes, but we also have hours. We want to only talk about one unit of time. You could choose the minutes or you could choose the hours. I think it's honestly easier to use hours because there'll be lower numbers. So 30 minutes is really 0.5 hours because it's really a half an hour. 15 minutes is really a quarter of an hour, or 0.25 hours. So in our equation, a small tattoo takes 0.25 hours, so 0.25x. A large tattoo takes 0.5 hours. She'll be at the fair for 6 hours. Now, this is another one that doesn't tell you specifically what symbol to use. However, she's going to be there for 6 hours. Could she be there exactly 6 hours? Sure. So, or equal to is definitely one of them. Could she be there for less than 6 hours? Sure. Could she be there for more? No, because they're going to be closed. So there's our two equations. What you want to do next is rearrange them for y equals. So minus 10x and minus 10x to get the y all by itself. You can't do a negative 10x plus a 200, but we can switch it around to be in y equals mx plus b form. Divide by 25s. So y is greater than, now here, negative 10 over 25. I'm going to show you a little trick. We can actually take that fraction and just reduce that fraction. We have negative 10 over 25. We can simplify it because remember, slope is written as a fraction, so we don't need to change it into a decimal. Divide by 5, divide by 5, we get negative 2 over 5. That's a lot nicer fraction than negative 10 over 25. And then 200 divided by 25 is 8. So there's our equation. For the second one, we would do minus 0.25x and minus 0.25x. So we have 0.5y is less than or equal to negative 0.25x plus 6. And then divide by 0.5, divide by 0.5, divide by 0.5. So we have the equation y is less than or equal to. Now, again here, negative 0.25 divided by 0.5. I could take and I could simplify that fraction. We could divide by 0.25 and divide by 0.25, and then I'm going to get negative 1/2. That's a lot nicer fraction when we simplify it. And then plus 12. So there's my two equations. Now I'm ready to graph these two equations. When we go to graph it, we said that x is small and y is large. So we're putting small down here, and we're putting large up along the side. I'm going to count by ones across the bottom. And I'm going to count by twos going up along the side. So when we go to graph this, my first point for my blue is at a y-intercept of 8. So I'm going to put a dot right there at 8. Now I'm going down 2 over 5 according to my slope. Be very careful, down 2 is not down 2 blocks, it's down 2 units. So that's really down 1 block and then over 5. So I'm going to go all the way over to here. Down 2 over 5, which is really down 1 block and over 5. I have a solid line because of the or equal to, and I missed there, so I'm just going to redo it really quick. I have a solid line. You should put arrows on the ends, and you should also label your line always. And now it is greater than, so I'm shading up above. For my second one that I'm going to do in red here, I start off at 12. 12 is right here. And I'm going down 1 over 2. Down 1 is down half a block, and over 2 is still over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. That again is a solid line. And this time I'm shading below it. So my double shaded area. My double shaded area ends up all in here. So for my solution, I can pick any point in that double shaded area. If I go, I could pick like, I could pick 110 if I wanted to, which is right there. I could pick 5, 8 if I wanted to. That's right there. Any point in that double shaded area would work perfectly good. So she could do like 5 small and 8 large, for example. These are sort of a pain in the butt to do, but you just got to rearrange for y equals and then graph them and find the double shaded area. Take a look at the next one. So this is our last example. The new theaters at the mall have 50 seats in them. You have adult tickets that are $15 each and children's tickets that are $10 each. They want to make at least $550 for each showing of Star Wars. So we have two things here. We have adult tickets and we have children's tickets. So I'm going to use X and Y. So I know right away on my graph that adult is going to be X and child is going to be Y. So when I go to do this, we have the number of tickets and then we have money. There are 50 seats total in the theater. Well, how do they come up with those 50 people? Well, they take their adults, add them to the number of children, and you have 50 seats total. Could they have less than 50 people at the movie? Sure. Could they have more than 50 people at the movie? No. Could they have equal to 50? Yes. So it's less than or equal to. For the second equation, we're dealing with the money part. Each adult ticket is $15. Each child ticket is $10. So 15x plus 10y. They want to make at least $550. So greater than or equal to 550. We need to, just like in the last one, rearrange it for y equals. So minus x and minus x. And there's our first equation. For the second equation, we need to do minus 15x and minus 15x. So we have 10y is greater than or equal to negative 15x plus 550 when we go to rearrange it. Divide by 10, divide by 10, divide by 10. So y is greater than or equal to, here's that trick again, negative 15 over 10. I can divide by 5 and divide by 5 to be negative 3 over 2. 550 divided by 10 is 55. So there's my other equation. When I go to number my axes, I want to count by 2's going across the bottom for the number of adult tickets. That's nice, just a nice, neat number that's easy to graph. And then going up along the side for children's tickets, I know that I could reach a lot more. So I could have up to 50. So I'm going to count by 10s. So when I go to graph it, so the first equation has a y-intercept of 50. So I could start right here. And then my slope, there's really a negative 1 in front. So my slope is negative 1 over 1. Now that's going to be sort of a pain in the butt to graph because it's 10 in going up and down and 1 over. So down 1 over 1 is going to be right below it. Down 1 over 1, now we're down to 8, and then we're down to 7, and then we're down to 6, and then we're down to 5, and then we're down to 4, and then we're down to 3, and we're down to 2, and then we're down to 1, and then we're down to 0. This is a very important point, all right? Over to 10, up to 40. If you typed it into your y equals and you did second in table, that point becomes very important. And then we keep on going with it. Down 1 over 1, 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 and we keep on going. So this is a solid line. And we are shading below the line. Then for the second graph, we're starting off at 55. 55 is right there in the middle. And then we're going down 3 over 2. So down 3 over 2. So we're at 52, 49, 46, 43, and then 40 is right here. Those actually cross right there. That's a point again, 10, 40. And then down 3 over 2, down 3 over 2, down 3 over 2, and it keeps on going. So these cross right there. Not exactly the straightest lines in the world. We should have labeled our lines. The other one real quick. And now we are looking for the double shaded area. The double shaded area in this one is actually this little sliver right in there. All right. It actually includes this dot right there because they're both solid lines. They're both solid lines. So they definitely include the intersection point of 1040. 1040 would be a great point to pick. You could pick like, it looks like 18 and 30 might be a good choice as well, right in here, 18 and 30. And that's how you do it. Sometimes the graphs are a little bit more difficult, but you just have to rearrange for y equals and then graph.